Hi everyone, and welcome back to Spaced Out. For those of you who don't know me, my name's Dia and I'm studying astrophysics at Caltech. Last time, we talked about the Drake equation and Fermi's paradox. As a quick reminder, the Drake equation is a framework for how we can estimate the total number of alien civilizations we can communicate with, and the Fermi paradox is basically the idea that life should be common in our universe, and it's paradoxical that we haven't yet found any other life. If you want a more in-depth explanation for this, check out my previous episode. Today we're talking about something very fun, the theories that try and answer Fermi's paradox. Basically, the theories that try and explain why, despite the size and age of the universe, we still haven't found any signs of extraterrestrial life. The first theory I'll discuss is the rare earth hypothesis. This idea is that microbial life might be common, but complex life, like humans, which we are ultimately looking for, is extremely rare. It argues that Earth has a very specific and narrow set of conditions that allowed intelligent life like us to evolve, and the timing of it had to be just right in order for us to form. Like, we needed a stable environment, the right type of star, the perfect distance from the sun, plate tectonics, a magnetic field, liquid water, and the list goes on. The idea is, the more precise the constraints for life are, the smaller the statistical likelihood of us finding the planets that meet these conditions. Think of it like this. If you're looking for a house, it's not that hard to find one. But if you're looking for a house with a specific number of bedrooms, it gets a little harder. Now, if you're looking for a house with a specific number of bedrooms and a specific number of bathrooms, it gets even harder. And if you're looking for a house with a specific number of bedrooms, bathrooms, and that fits into a specific price range, it gets even harder. This idea is the same. The more constraints we have, the harder it is of finding the planets that meet these conditions exactly. So maybe the reason we haven't found aliens yet is because planets with all the perfect conditions are just incredibly rare. The next theory is called the Gaian bottleneck hypothesis. This theory is kind of similar to the rare earth hypothesis, but with a slightly different focus. The rare earth idea said that complex life is rare because the right conditions for life almost never exist. But the Gaian bottleneck hypothesis says maybe those conditions do exist, and life does start fairly often. It just doesn't last very long. Now, for life to survive long term, it has to evolve quickly enough to regulate and stabilize its environment. On Earth, for example, microbes eventually released oxygen into the air, which made the atmosphere better for plants and animals. And the life also helped keep the planet's temperature and air balanced, kind of like how a thermostat regulates the temperature in your house. Now, plants, oceans, and even bacteria help control things like carbon dioxide and keep the planet steady and livable. But on most planets, early life might not have time to do all that. It can get wiped out by freezing, overheating, maybe asteroids are hitting it, or maybe even other unstable climate conditions before it becomes complex. Think of it like lighting a match for a campfire. Now, getting the first spark is easy, but unless you carefully tend to the fire, it'll just go out before it really catches. So maybe lots of planets briefly had life, but it died out too quickly for us to ever detect it. That's the idea of the bottleneck, the tough early stage that most life can't get through. And remember, one of the key parts of the Drake equation is the lifetime of civilizations, because even if life starts, it has to stick around long enough and be stable enough for us to ever notice it. This next one is really intriguing. The Great Filter theory says that there's some critical step in the evolution of intelligent life that is very hard to pass. Think of this like climbing a staircase, but each step gets progressively steeper and harder to step on. At one point, the next step is incredibly hard to make, and it could be the Great Filter. This theory assumes that all life in the universe follows the same basic steps to reach where we are now, from basic chemistry to a species dominating the planet and attempting to explore the solar system. This filter suggests that one of the steps in evolving life is so hard, borderline impossible to overcome, that most life forms fail at it. Now, this filter could be something we already passed, like the actual origin of life or the development of complex organisms, but it also could be something ahead of us, like surviving climate disasters or even the rise of artificial intelligence. If the filter's behind us, it suggests that we haven't found aliens because life like us is really rare. And if it's ahead of us, it indicates that civilizations potentially self-destruct before we're even able to detect them. Now, in this next section of the podcast, I'll share some theories that are more based in science fiction, but nonetheless have roots in science. Now, this one is called the zoo hypothesis, where aliens know we're here, but they choose not to interact with us. Rather, they observe us, kind of like how we observe animals in a zoo. This idea was first formally proposed by John Ball, an MIT astrophysicist. He argued that just like humans sometimes avoid interfering with developing ecosystems or tribes that haven't been contacted, aliens might have some sort of ethical reasons to let younger species like us evolve on our own. Maybe we haven't heard of aliens because they've chosen to watch us silently, waiting for us to reach a certain level of maturity or technological development. And this theory draws on some real ideas from ethics. Another idea is that we're simply not looking for the right signs of life. Imagine a civilization that has advanced and evolved so far past our understanding of biology that they're no longer biological. They wouldn't have the biosignatures that we usually search for when we look for life, like carbon or oxygen. They might be made of entirely different stuff and communicate in ways that we can't even imagine. Perhaps we're limited by our pre-existing knowledge on what life is, so we can't even imagine what to look for, and we're missing the clues. I will end with one people might be more familiar with, the dark forest theory. It comes from a sci-fi book called The Dark Forest, and it's a more sci-fi answer to the Fermi Paradox. It's framed like this. Imagine you were walking through a dark forest at night. You can't see who's out there, and you want to avoid making noise to avoid the danger. So you stay quiet and you stay hidden. And you listen carefully, because you assume everyone else is doing the same. That's the idea of the dark forest theory. The universe might be full of life, but everyone could be staying silent on purpose. Not because they're not out there, but because making yourself known might be dangerous. Any civilization that announces its existence could be seen as a threat by another, so they could be choosing to stay silent to be safe. This idea is largely based in game theory, and simply explained, it's a situation with high uncertainty, kind of like the commonly known prisoner's dilemma. Everyone's making decisions without knowing what the others will do, so they will assume the worst to survive. It's like the physical embodiment of better safe than sorry. So where are the aliens? That's what the Fermi Paradox asks, and that's the question all of these theories are trying to answer. Maybe intelligent life is rare. Maybe intelligent life is fragile. Maybe it's hiding, or maybe it's all around us, and we're just not looking for the right signs. Whatever the answer may be, the search continues. Thanks for listening to this episode. If you enjoyed this episode and you have ideas for other ones or topics you want explained, you can reach out to me on my Spotify or my contact information's on my website. See you next time.